Hello everyone, welcome back to Hypothetical. In previous video, we have discussed about re-ranking concept. In this video, we are going to discuss about query transformation. So, without wasting any time, let's begin. So, query transformation is nothing but improving the particular user query before sending into the retriever. So, let's proceed with the problem. So, imagine we have a data like this. Suppose if I ask simply, if I ask, tell me about EMP001. It's good. I mean, for knowing about this particular employee, it's a good prompt, right? I mean, it's a good query, right? Suppose if I ask something like AI, so what should the particular LLM respond? I mean, what answer should it give? Should it give AI is the future or AI is transforming healthcare? So this is considered as a bad query, right? So for optimizing this, query transformation plays a vital role. So before sending this to retriever, so it goes to an LLM. I mean, here this particular prompt, which is given by us AI, goes to a particular LLM. It scans our prompt and optimize the prompt. Like, tell me about AI, anything it might be. It optimizes the prompt like this automatically and then sends this particular prompt to retriever. Got it? So this is what query transformation means. So better query means better retrieval. Better retrieval means better answer, right? This is what we want, right? So we'll use this particular query transformation concept. Got it? So let's go deeper. So for this particular query transformation, there are four different types of methods. Query writing, query expansion, multiple query retrieval, and HyDE, HYDE method. So now let's discuss about query rewriting. So query rewriting is nothing but uh yeah, let me proceed with this example. When a user gives this particular query, it generates another query which is optimized than this. So this is what query rewriting means. So let's continue with our hybrid search where we have performed re-ranking also. So here we have given our query. Tell me about EMP002. Suppose if I give only EMP002. Now let's optimize this query, guys. So first of all, for giving a particular context to AI model, what should we do? Should give a particular prompt, right? We need to give a prompt. So our prompt not something like prompt 0, which is equals to yeah, you are a prompt optimizing AI assistant. You need to optimize prompt and make it structured so that AI model can easily understand it. So, or prompt query. So this is a prompt, guys, right? Let's do one thing. So let's keep this before. Yeah, this is fine. So now, so here let's give something like rewritten query so that it gives the query instead of any unwanted matter. Yeah, a response equals to LLM dot invoke or prompt not. So it's fine. Let's see what it gives. So as we can see here are the optimized prompts. Provide information about employee ID EMP002, including job title, department, and other relevant details. Yeah, retrieve employee data for EMP002. Yeah, these are optimized prompts, right? But from the output, we can see that there are many prompts, right? So let us also tell that only give one prompt, like a small query, which is the best one, without any random text. Yeah, it's fine. So as we can see that it has given something like what is the meaning or significance of code EMP002? Means we have only given this particular text, but it has generated a good question where an LLM can answer it, right? So this is what an optimized prompt is. Got it? So by this, mm, we can give to an LLM, right? So let's do one thing. I'll create a variable called optimized prompt is equals to response dot content. So again, now we'll give this particular optimized prompt as prompt to this query. I mean this response. Got it? Yeah. Okay. I think it's not a good idea. Let's do one thing. So mm, instead of doing this, we'll equal it with our query, guys. So our query equals to response dot content. It's good. So I'll cut it and paste it here. So this can generate our content. Got it? Yeah. So here, this response, I mean, this particular response variable will handle our query. I mean, for optimizing our query. So here, this particular response will handle the response, the original response which we need, right? So I'll run it. So we have got a response like the code EMP002 refers to an employee identifier, especially for an employee who works at HR department. So we have got an optimized answer from an optimized query, right? So this is what optimization means. Got it, guys? So let's discuss about the second method, which is query expansion. So let me clear the terminal. So here the query expansion adds more relevant keywords to our prompt, I mean to our query to make retrieval search more efficiently. Suppose, let's take this document as an example. And if I ask something like EMP001, so this particular query expansion generates the responses, I mean, generates the more queries like about EMP001, who is EMP001. It adds more keywords to it for making this particular query complete, right? What is EMP001? Like that. Got it? EMP001 details. So these all keywords goes to the particular retriever and they can give the responses according to it. So let's go to our hybrid search. And now let's take this particular variable as an example. This prompt is 0. Let's edit this. So what should we give? You are an AI assistant. Expand the following query using relevant keywords. Do not answer the question. Just return the keyboard. I mean keyword, sorry. Yeah, that's it. And let's also remove this execution time score. No need. It's fine. So let's see our expanded prompt. Yeah, I'll comment this. Here the prompt 0 goes to response. Okay, let's print query. Fine. So let's run this. Okay, it has given the many keywords. Employee ID, EMP002, employee details, employee profile, employee information, many, right? So from a single from a single text, we have generated a good content. So I mean we have expanded. So this is called as query expansion. Let's do one thing. So in the prompt, let's give something like select and give the best one among all. Okay, let me keep this at okay. Let's place it here, no problem. Yeah. Now let me run this. Fine. So as we can see that it has returned employee ID EMP002. It's good, right? So let's do one thing. So our query will be sent to this. Yeah, it's good. Okay, let's remove this print statement and let me clear the terminal. Yeah. So employee ID EMP002 works at HR department. So we have got a response. It's totally fine, right? From a simple keyword, we have got a response like this. It's good. Yes, so this is what query expansion means. So now let's discuss about multi-query retrieval. So first of all, this multi-query retrieval takes our query and generates the multiple queries from them. We can find the best output. So this is the architecture of it. When a particular user asks a query, it generates the multiple queries. Assume it generates 4 queries, and these all goes to the particular hybrid search, anything it might be. It might be a vector search or a keyword search. So then it merges all the results through these queries and removes the duplicates from them. And then the re-ranking occurs. And finally, it goes to the particular LLM like Groq, Gemini, OpenAI, like ChatGPT, anything it might be. So this is used to find good output. So let's generate a prompt like yeah, from this. You're an AI assistant. Take this query and generate 4 different queries based on it. Return one query per line. Yeah, it's fine. Good. So LLM dot. So let's print our query first of all. Also, let's comment this. Good. Yeah. Let's run it. So we got multiple queries, right? What is the job description of employee EMP002? From what? It's just from a normal query, right? So now it's done, right? So I'll create a variable called mm, all results, which is a listed data structure for each of the following in query. I mean, we have generated four queries, right? So here in all, in every query, just do one thing. Do vector search and keyword search for both of them and append the results to here. Got it? So let's do one thing. Let this query be a list data structure for performing loop inside it. Dot split method. Yeah, right. Now for queue in queries, I mean in query, so let's perform vector search and keyword search. Vector results equals to vector retriever dot invoke. So this is the method for performing the vector search dot invoke our queue, a single query, right? So now let's perform keyword search. Keyword results equals to bm25 dot invoke queue. Good. So what should we do now? So we need to append this particular results into this all results list, right? So all results dot extend vector results and also let's keep our keyword search results, keyword results. Yeah, it's fine. So it's fine, but here we can see some duplicates at maybe the keyword results and vector results equal. Then we can see some duplicates right here. So we need to remove these duplicates. So for that, okay. So for that, for S in all results, so I'll create a variable called scene, which is a set data structure. It's fine. So I'll also append the unique elements in a list data structure. Yeah, I'll keep something like this, just normally. So, so if S not okay, S dot page content, if it is not in our scene, I mean, if it is not in our set, so then we should append it, right? Mm, uniques dot append doc. Yeah, we have given the variable s, right? So for that, so also our scene dot add our s. Got it. So now, so I'll run this, guys. So let me clear the terminal and let me remove this print statement and let's go. So we have got a response like EMP002 works at HR department. Means it's working good. So our last and final topic is HYDE, hypothetical document embeddings. So let's discuss about it. So let's start with an example, guys. So suppose a user asks, hmm, okay, let's talk irrespective to this documents. So imagine we have a document about RAG. So tell me about RAG if I ask. So first of all, when we ask this query, the hide generates an answer for this, a small answer for this. This entire answer goes to the retriever instead of this question. So imagine we have an answer for this like RAG is an AI technique which is mm, mm, which combines our document with an LLM like Gemini, Chat GPT, anything it might be, and retrieves, okay, sorry, returns the responses to us irrespective of external knowledge. Yeah, this is a good answer for RAG, right? So first of all, when I ask this question, this particular technique, hide technique generates an answer something like this, and this answer goes to the retriever instead of this question. I mean this query. Got it? This is also known as a popular technique because this particular answer goes to the retriever and it returns the answer, which is quite similar to this, right? It will be similar somewhat, right? So it takes less token usage. Now let's get back to our file and let's edit this prompt. Yes, you are an AI assistant. Generate a hypothetical document for this query, and it should answer the user question. And do not mention that it is hypothetical. It's fine. And let's do one thing. Let's edit our document because this retrieval technique will not be used for exact searching. I mean, it's like a keyword search, right? So it will not be useful for data like this. So let's edit our document. I mean, let's discuss clearly. If we give this as a query, it cannot generate an answer, right? I mean, it cannot generate a hypothetical document generally, right? Because it don't know what is this. We are not giving our content. We are giving only our query, right? So for that, this document may be useless. So let's take another one. Let's take RAG as an example. Yeah, just copy paste the previous one. Fine. Just a basic definition. Yeah, it's fine. So I'll ask about what is RAG. Good. So let me clear the terminal and write. So we got a response. RAG is an AI technique that combines documents with a large language model (LLM) and returns responses irrespective of external knowledge. So it's good. Also, we got a response very fast because this particular answer which is generated is similar to this one, right? So this answer will go to the retriever and the retrieving becomes simpler, right? Because the embeddings for these both will be almost equal, right? So for that, it will generate the answer very simply. Cool, right? So this is HyDE, which is an optimized technique, very widely used one. So that's it for today, guys. So in this video, we have covered complete query transformation techniques, which are very important. So in next video, we are going to discuss about context compression, which is an efficient technique. So stay tuned and Jai Hind.